pre, like before the arguments. Right? So writing it this way with a function to the left, so to speak, is called prefix notation. And if you write it this way, where the function symbol, in this case plus, the function symbol is in the middle, and here are your two arguments, right? Your two input values. So this way is called infix, in, like inside. Infix format notation, writing it that way. And writing it this way is prefix, because the function symbol is, it precedes, before, on the left side, the arguments. And here the function symbol is like in between, or inside the values of your arguments. Okay? So be familiar with the two ways. There's prefix notation, this way, and infix notation, this way. Now, prefix notation, I've read, that sometimes gets referred to as the Polish, as in Poland, the Polish notation as well. So, just a matter of interest. All right. Now, two more concepts. Again, in the context of functions. The idea of, three actually, but the concept of predicate and relation. And they're closely related. In fact, you'll probably be asking, what's the difference between those two? Don't really see any difference if you give it some thought. Anyway, so we'll start with predicate. Now, there's a synonym for predicate, it's property, and in this text, this particular author tends to use these two almost synonymous, pretty well synonymously. And you mix, you'll use one and the other, and they're the same meaning. Okay? So when you think predicate, just think property, or property, think predicate. So what is a predicate? Well, it's a function whose output is either true or false. In other words, its range, the set of output values. The set whose output values belong to, strictly speaking, a bit different, like I was saying earlier. Okay, so a predicate is a function whose range is this set, true or false. In other words, it's a function that decides whether something's true or false, depending on the input. Okay, so think of a predicate as a function. Stuff comes in, and this function decides, depending on the input, whether the output should be true or false. True or false. Or to shorten things, I'll end up just using T and F, right? So I don't have to write out the whole word. Okay. So if the output is true or false, that function is a predicate by definition. Okay. Fairly clear, or you could call it a property. Well, you may ask, why the choice of labels? Why would it be called a property? Well, I suppose you could say, given the inputs coming in, does that set of that combination of inputs, does it have a certain property? Yes or no, true or false, right? Maybe in that sense. But it doesn't really matter, they're just definitions, they're labels, okay? But it's nice to have a label that fits the context to some extent. So let's just think of predicate as something that's true or false. The output is true or false. So the range is the set of these two. Okay? Now let's do an example. Let's say the function even. So let's say it's a unary function, in other words, one input. Okay, and let's say the domain. Let's say the domain of that function even is z, big Z. Okay, set of integers. Let's say, right, and what it does is it will output true. It will return true, it will output true if the input integer is an even number, okay, an even integer. Okay? And it'll output false if the input integer is an odd integer, not even. Okay? Pretty simple. So here's an example. So even applied to this input value 4 will output the value true. Okay? So even of 4 is true. And if you input 5, that's an odd integer, it is not even. So this function applied to that input value will give you the output value false. Okay? So even of 5 is false. So this function here, even, is a predicate. Right? Predicate is a function that gives you as output either true or false. Okay? Right? Now, what's a relation? Well, it's a predicate, or property, same thing, remember? So I see. Now I've just written this out from the text. So the textbook writer, Sipser, just mixes these two. Okay, so he's called here. He did not use the word predicate. He used the word property. Okay. Now the domain. Remember, that's the set of possible inputs. Now the domain here is. He's saying is a set of k tuples. Here's your k tuple. So you have k inputs now. So that means the domain is this tensor product, k times. Right? Now these all. I'm not sure if these sets are all identical. They're the same set. I'm going to check that. That's important. Hold on. Sometimes I catch myself in my little details. So what are we talking? Predicates. No, he says they're all the same. He doesn't say A1, A2, ... AK. He just says A times A times A times A. Okay, so this is what's in the textbook. Okay. Okay, so if you ask yourself then the question, what's the difference between a relation and a predicate? From what's been said in the text, my interpretation, see what you think, is that really the only difference is that the relation is just a special kind of predicate where the inputs are multiple. I don't see any other real difference except now wait a minute, here may be the thing. See, he didn't spell this out, so I have to deduce it. But the possible, you're talking a tensor product with itself. It's the same set each time. Okay. Here's made more explicit. So it's a k-ary relation. So when you have this input, which are the k tuples of this tensor product, where they're all the same A. Okay, you don't have k different sets. You just have k sets, but they're all the same set A. Okay, so these values here, they all belong to set A. Okay, so a relation is then a predicate where the inputs each there's k of them, and each input is a member of A. Okay, and you have k of them. So a relation could be a k-ary relation on A, on this set A. Okay. Now, if you have a binary relation, so in other words, A cross A, right, that would be your domain. Then often you will not use the prefix notation. You won't write it like this, with the F here. You'll use the infix because binary relations are so common. So mathematics tends to use the same notation of infix notation because it's just sort of more familiar. It's closer to the way we speak. Like A is greater than B. Like for example, 2 is less than 3. So the function here relation. Now, the output of that. Now, if we put this, if we wrote it in prefix notation, so that would be your F, and these are your two inputs, right? And they're both from the same set. Well, we'll say Z, big Z. Okay. So that's your F, and your domain now would be Z cross Z, right? And the output of this will be true or false. So so your function is less than. Now, is 2 less than 3? Yes, it is. That's true. So output true. Okay. All right. So, but that that is prefix notation, whereas this is the more usual way we use in ordinary speech, ordinary conversation. Is when we say 2 is less than 3. Right? We don't say less than 2, 3. That's a bit stretching things, right? So so we use infix notation when typically for binary relations. Okay, now that's getting a bit subtle. It tossed me up. I had to think my way through it in real time. So the difference between a relation and a predicate. A relation is a particular kind of predicate when your inputs, multiple inputs, but each input from the multiple inputs, they are members of the same set. Okay, and of course, so relations are predicates. So the output will be true or false. Right? So relation is a special kind of predicate with this. That's the critical thing, I guess. Now you didn't spell this out, but I assume that's what's meant. Right? Well, I need to change the camera angle.